Today we're going to look at how we can solve word problems using what we've learned about equations so far. The first thing we need to do is review or maybe introduce for the first time some vocabulary so that when we read a word problem, we know mathematically what it translates to. So I've made a separate chart. Write down what you need to. If it's just review for you, you may not need to write anything down. And then I'll also send this chart to all of the Math 1 teachers. So if you want a copy of it, you can have a copy of it as well. So we have some keywords. This is by no means a list of every word that we could be using for addition, subtraction, multiplication, or division. But these are just kind of the more common ones. So words that mean addition are things like plus, sum, increased by, more than, or added to. Some words that mean subtraction are things like minus or difference, decreased by, less than, subtracted from. Those words are signaling subtraction for us. For multiplication, words like times or product, and then any of those words that have special meaning like twice, meaning times 2, or double times 2, triple times 3. And then division, words like quotient or half or a third or, words like that, you're usually signaling divisions or signaling division. And another kind of common one is when we say something was split evenly. So that's a pretty common division word. So if you'd like to write these down, feel free to pause and add them to your notes. But I will also make sure that you have access to a digital copy of this too. So some really basic examples. We just want to focus on the translation part. We're going to translate each written expression into a math expression. So when we do this, we're going to use some variables, and we'll talk more about variables in a minute. But we're going to use some variables to represent what's going on. So in number 1, it says Juan's salary plus $125 is $600. So we don't know what Juan's salary is. So I'm going to use an S for salary. And then I see this buzzword plus. So plus 125 was not on my list, but is usually signals that we're going to have an equal sign. So his salary plus 125 is 600. So that's taking a sentence and translating it into a math sentence. Number 2 says 6 times as many visitors is 120 visitors. Well, we don't know how many visitors there are. We don't know the actual amount. So I'm going to use the letter V for visitors, and I'm going to say 6 times. So times is my buzzword there, meaning multiply. So 6 times however many visitors there were. Then I see that word is again, so equals 120. All right, number 3 I think is kind of tricky. It says 27 is 7 fewer students than last year. The words fewer and than, when we throw that than word in there in particular, we've got to pay careful attention to the order and think about what's really going on. So last year, there were some number of students. We don't know how many students there were. Actually, I'm going to back up. I'm going to go in the order that they wrote. So they said 27 is. We've been seeing that is word, and we've been saying that that means equals. So I'm going to say 27 equals. If we have 7 fewer students than we did last year, and I don't know how many there were last year, I'm going to say S for students minus 7. And I'll tell you why the order is maybe reversed from what you think it is. This word than typically means reverse the order from kind of how you're reading. So we have 7 fewer than last year, which means I need to subtract 7 from the number for last year. All right, take a second, pause, try number 4 if you want. So number 4's got a couple parts. It says 3 more than. So remember, more than was an addition word. 8 times as many trees is 75. So we don't know how many trees there are. So 3 more than 8 times the trees. 2 different ways you could write this. I'm going to write 8 times T for 8 times the trees, and I want 3 more than that. So I'm going to add a plus 3 is 75. In that problem, we could also write 3 plus 8T, but I did put that that order, because again, I saw that than word, which usually means reverse the order of what you're reading in your actual sentence. So now let's take it a step further. We're going to not just translate, but we're going to use this to actually solve problems. So in our steps, I'd say the first thing that is helpful is to define your variable. So tell me what letter you're using and what does it represent. The second step would be to write the equation. And the third step would be to actually solve. So we've got a couple of examples for you. In number 5, it says, suppose Best Buy has their 16 gig iPad 2 on sale for $40 off the regular price. If the sale price is $389, find the regular price. So my variable is usually whatever I'm solving for. So in this problem, I see where it says find the regular price. That's what I don't know. So I'm going to use, I'll use the letter R for regular price. And I write that down just so I remember what it is I'm trying to focus in on. So if I'm going to use letter R to represent regular price, now I need to write an equation. It says the iPad is on sale for $40 off. So think about when we have something $40 off, we're discounting that or subtracting $40 from the original price. And then I know the sale price, whatever that amount is $389. So a lot of these basic ones that we're doing here, you could probably do in your head without an example, but we want to start basic and then build into some more challenging things. So now we know how to solve this. We would add 40 on both sides. So this is step 3, is to actually solve. And we get that the regular price is $389 plus 40, which would be $429. So that iPad is regularly $429. All right, let's do another one. It says, suppose 5 people won a cash prize. If the money was evenly divided and each person received $70, how much was the total cash prize? So again, I'm going to look at what it is I'm trying to figure out. Total cash prize is what I want to know. So you can use whatever letter you want. I'm going to call it T for total cash prize. If you prefer to use X every time, that's fine. But we do want to be comfortable, at least when people use other letters, being okay with that. All right, so here's one of those words. The money was evenly divided. So we took some total cash prize and evenly divided it between 5 people. So I can represent that as T divided by 5. And what I know is that when that happened, each one got 70. So I can write T divided by 5 equals $70. So now we solve this. These are all one-step equations. T divided by 5, to get that T by itself, I do the opposite. So I multiply by 5 on both sides. And that tells me that the original value of the cash prize was $350. All right, if you are feeling good about this, pause, try number 7, and then turn back on when you're ready to check. In number 7, it says Hugo received $100 for his birthday, then saved $20 each week until he had a total of $460 to buy a new gaming system. The question is, how long does it take Hugo until he's saved a certain amount of money? So what I need to know is how long it's going to take. And when I decide on my units I'm going to use, I'm reading in my problem. The units of time here are weeks. So I'm going to stick with the units that are already in the problem, and we're going to solve for the number of weeks. So I'll use W for the weeks. And now we write our equation, step 2. So it says he got $100 for his birthday. So he has 100. And then he saves $20 each week. So for every week that passes, he saves another $20. And I represent that with a 20W. So same idea as slope when we did linear equations, something happening repetitively. And he's going to end up with a total of $460. And now this is a 2-step equation. We've taken it a step further, and now we want to solve this. So remember, in solving this equation, we would subtract 1 on both sides, or 100 on both sides. We get 20W equals 360, and then divide by 20. We get W equals, we need to do 360 divided by 20, which I believe is going to be 18, but I'm going to double check on my calculator. Yep. So it will take him 18 weeks until he saves $460.